Generative AI is evolving from a tool that simply answers questions into an active participant in business operations and decision-making. As this transformation continues, the scope of AI governance must expand beyond the AI model itself to include the knowledge that AI uses to make decisions. AI makes decisions based on many forms of knowledge, including internal policies, operating manuals, contracts and regulations, business systems, external data, and communication histories. In environments where multiple AI agents collaborate, their decisions and actions are strongly influenced by which knowledge they receive, where it comes from, what it means, and how trustworthy it is. If unreliable information or outdated rules enter the flow, even a highly capable AI may make decisions that are undesirable for the organization. Therefore, governing AI decisions requires us to govern not only the models, but also the flow of knowledge itself. In this presentation, we will move beyond traditional model governance and explore how AI governance can be designed through knowledge flow. Today, the use of AI is expanding across virtually every area of business. AI searches internal documents and presents relevant information. It responds to inquiries from customers and employees. It analyzes customer challenges and creates sales proposals. It reviews contracts and identifies potential risks and important considerations. It detects early signs of equipment failure from operational data, and it organizes information needed by management to support decision-making. In this way, AI is becoming more than a tool that simply answers questions. It is becoming part of business operations, interpreting information, presenting options, and sometimes determining the next action. However, as AI becomes more deeply involved in decision-making, a new question arises. Is an answer that sounds natural necessarily an answer the organization can trust? What evidence did the AI use to reach its decision? And can its answer truly be trusted? Generative AI can produce fluent and persuasive answers. However, an answer that sounds natural is not necessarily correct within the context of an organization's operations. We may not know whether it complies with internal rules and approval requirements. We may be unable to verify the source materials behind the answer. The AI may refer to expired policies or outdated documents. The same question may produce different answers across departments, and we may not know how much decision-making authority or autonomy should be given to the AI. As long as these issues remain unresolved, organizations cannot confidently use AI-generated answers for critical business decisions. The important point is that these problems are not all caused by the performance of the AI model itself. AI decisions are influenced by more than the model's capabilities. What kind of knowledge is reaching the model? That is another critical factor determining whether AI decisions can be trusted. AI models have advanced reasoning capabilities, natural language generation, pattern recognition, and broad general knowledge. However, these capabilities alone are not enough to make decisions suited to the specific circumstances of an organization. Business decisions also require internal policies, the latest contractual terms, the reasons behind similar past decisions, and the current context of operations and customers. For example, no matter how capable an AI may be, if it is given only outdated contractual terms, it will produce answers that do not reflect the current agreement. If the necessary internal policies do not reach the AI, it may make recommendations that are generally reasonable but violate the organization's rules. In other words, the quality of an AI decision depends not only on the model's performance, but also on which knowledge was available at the moment of decision. Even a highly capable AI cannot make an appropriate decision unless the right knowledge is delivered in the right form, at the right time. So, what kind of flow is needed to transform information scattered across an organization into knowledge that AI can use, and deliver it reliably? This end-to-end process is what we call knowledge flow. Knowledge flow is not simply a mechanism for passing documents and data directly to AI. First, internal and external documents and data are continuously collected through ingestion. Next, extraction identifies important concepts, conditions, relationships, and decision criteria within the content. Ontology defines the meaning of the extracted information, while a knowledge graph structures the relationships among it. Internal rules and decision conditions are then converted into policies or a domain-specific language, DSL, that AI can apply at runtime. This organized and validated knowledge is managed in a knowledge repository and delivered to AI agents according to user permissions and the current context. The AI agent makes decisions based on the delivered knowledge, then records the result and its reasoning as a decision trace. In other words, knowledge flow is the process of transforming information scattered across an organization into actionable organizational knowledge, with defined meaning, relationships, rules, and trust, and connecting it directly to decision-making. The important point is that governed decision-making cannot be achieved simply by finding relevant documents and passing them to AI. Today, many organizations use RAG to enable AI to reference internal documents. RAG searches for documents related to a user's query and passes their content to an LLM to generate an answer. It is highly effective for incorporating organization-specific information into AI responses. However, a document that is relevant to a question is not necessarily knowledge that should be used for a particular decision. A retrieved document may not be the latest version. Similarity search alone cannot determine whether it is appropriate for the current business context, whether the user has permission to access it, or whether it complies with organizational policy. Knowledge flow evaluates not only the validity of the knowledge, but also the current context, the applicable policy, the available authority, and the level of trust associated with the AI and the information involved. By combining these elements, knowledge flow moves beyond a simple LLM response and connects it to an organizationally governed decision. RAG finds relevant text. Knowledge flow delivers trusted knowledge that can be used for decision making. Therefore, AI governance must examine not only the generated answer, but also the state of the knowledge that produced it. When evaluating an AI decision, we tend to focus only on the final answer or the outcome of the action. However, the output alone does not tell us why the decision was appropriate or what risks existed behind it. What we need to examine is the state of the knowledge at the moment the AI made its decision. What did the AI know? Conversely, what necessary information did it not know? Which rules or information did it prioritize? Was the referenced knowledge current and valid at that time? Did the AI have the authority to use that knowledge? And was it aware of any conflicts between the available information and rules? Only by examining these conditions can we determine whether the AI's decision was appropriate. In other words, governing AI decisions means more than managing outputs. We must also govern the meaning, relationships, evidence, and validity of the knowledge used in decision making. This is why traditional data governance alone is no longer sufficient. Traditional data governance has focused on managing data quality, ownership, access permissions, and retention periods. These remain essential foundations for the use of AI. However, AI decisions rely on more than data values or documents themselves. We must also govern what the information means, how it relates to other information, what evidence supports it, and how long it remains valid. In other words, we need to govern its state as knowledge. For example, organization-wide policies, department-specific exceptions, and individual customer agreements may all exist at the same time. Simply storing these files correctly does not tell us which conditions should take priority. The AI must understand their meaning and relationships within the current context, then combine the appropriate knowledge for the decision. This is the role of knowledge governance. Decision governance then manages which decisions that knowledge applies to, what actions may be executed, and who is responsible for them. From data governance to knowledge governance, and from knowledge governance to decision governance. To establish this continuous chain of governance, we must manage the entire life cycle, from the creation of knowledge, through its use in decision making, to the recording of the resulting decision. Knowledge flow governance consists of 7 elements. The first is the knowledge source. This identifies the document, database, business system, or external source from which the knowledge originated. The second is ingestion. This manages when the information was collected, from which scope, and under what conditions. The third is extraction. This verifies which concepts, conditions, relationships, and decision criteria were extracted from the documents or data. The fourth is ontology. Ontology gives the extracted information a shared meaning and resolves differences in interpretation across departments and systems. The fifth is the knowledge graph. It structures the relationships among different pieces of knowledge, making it possible to examine their background and dependencies. The sixth is policy and DSL. These express internal rules and decision conditions in a form that AI can validate and apply at runtime. And the seventh is the decision trace. It records which knowledge and policies the AI used, and why it reached a particular decision. The important point is not simply to manage these elements individually. It is to govern the entire knowledge life cycle, from the original information source to the record of the final decision, as one continuous flow. That life cycle begins with 3 stages: source, ingestion, and extraction. To create trustworthy knowledge, governance must begin before information is extracted, not only afterward. At the source stage, we clarify the creator of the information, ownership and accountability, the date of the latest update, its validity, and its confidentiality level. Who created it? Who is responsible for its content? When was it updated? And is it still valid? What confidentiality classification does it belong to? Information without clear answers to these questions cannot be safely used as evidence for AI decisions. The next stage is ingestion, where we manage what information is collected, how frequently it is updated, who can access it, how long it is retained, and under what conditions it is deleted. Even when the source is reliable, outdated knowledge will reach the AI if updates are not properly reflected. At the extraction stage, every extracted piece of knowledge must remain traceable to its original source. Extraction accuracy must be validated, with human review when necessary. Verification by multiple models and the management of approval status can also prevent incorrect interpretations from being established as knowledge. In other words, trustworthy knowledge requires a reliable source, controlled ingestion, and verifiable extraction. However, traceability to the original source alone does not enable AI to understand the information within the organization's context. The next stage must give the extracted information clear meaning and structure the relationships among it. Even the same word can have different meanings across departments and business functions. For example, customer, member and user may refer to the same person, or they may represent entirely different roles. Terms such as case, opportunity, and project can also have different definitions and scopes depending on the organization. Likewise, approval, confirmation, and authorization may appear similar but require different levels of authority and responsibility. Ontology clearly defines these meanings and distinctions. It organizes the vocabulary, concepts, and classification systems used within an organization, creating a shared foundation that both humans and AI can understand consistently. A knowledge graph, meanwhile, represents how those concepts are connected in real business operations. For example, a customer has a contract for a product. Specific maintenance terms apply to that product, and a responsible manager has approved an exception. A knowledge graph connects these relationships, enabling AI to understand not only individual pieces of information, but also the broader business context. Ontology defines meaning. The knowledge graph connects context. Together, they transform information into structured knowledge that can be used for decision-making. However, understanding meaning and relationships alone is not enough to govern AI actions. The next step is to convert organizational rules into a form that AI can evaluate at runtime. Organizational rules are often written in natural language within policies and operating manuals. For example, payments of 1 million yen or more require approval from a department head. A human can read this sentence and understand its meaning. However, for an AI agent to apply the rule reliably at runtime, it must be converted into a machine-evaluable format. This is where policy and DSL are used. Policy defines what is permitted, what is prohibited, and under which conditions human approval is required. DSL expresses that policy as specific conditions that can be evaluated at runtime. For example, if a payment is 1 million yen or more, approval from a department head is mandatory. The external transmission of personal information is prohibited. Contract changes require legal review. An emergency safety shutdown may be executed automatically. High-risk cases must be escalated to a human gate. By making organizational rules executable in this way, AI can do more than generate answers. It can verify conditions and authority before taking action. Natural language explains what a rule means. Policy and DSL control AI execution according to that rule. However, even clearly defined rules cannot ensure safe execution if the knowledge used in the decision is not trustworthy. The next requirement, therefore, is a mechanism for evaluating the trust level of knowledge. Not all knowledge can be trusted equally. An official policy and a note with an unknown author, approved contractual terms and a draft still under review, current data and outdated information that has not been updated. These cannot be given equal weight in decision making. That is why the trust level of each piece of knowledge must be evaluated. The evaluation includes source reliability, which indicates the trustworthiness of the information source, whether the source has legitimate authority to issue that information, whether the required approval has been obtained, freshness, which indicates whether the information is still current and valid, consistency with other knowledge, extraction accuracy, which shows whether the information was correctly extracted from the original content, traceability, which makes it possible to verify the evidence back to its source, and past performance, which reflects the outcomes the knowledge has produced in previous decisions. By combining these factors, we can dynamically calculate a knowledge trust score. When knowledge has a high trust level, AI may be permitted to make autonomous decisions within a defined scope. When its trust level is low or cannot be verified, the decision should be escalated to a human gate for review. In other words, the level of autonomy granted to AI should be determined not only by the model's capabilities, but also by the reliability of the knowledge supporting its decisions. And that reliability is not a fixed assessment. It changes as knowledge is updated or expires, and the autonomy granted to AI must change accordingly. Some knowledge remains valid for a long time, while other knowledge becomes outdated as time passes or circumstances change. Contract terms, internal policies, prices, customer information, and maintenance histories are continuously updated. When knowledge is current, valid, and sufficiently trustworthy, AI may be permitted to act autonomously within a defined scope. However, when knowledge has expired, has not been updated, or is incomplete, confidence in the AI's decision decreases. Continuing to grant the same level of autonomy under those conditions would be dangerous. For example, if the latest contract criteria cannot be verified, automatic approval should be suspended. If maintenance records are not up to date, equipment-related decisions should be escalated to the responsible person. If the required knowledge cannot be verified, the AI should be limited to making recommendations, with the final decision returned to a human. The important point is not to stop the AI only after a problem occurs. We must continuously monitor the freshness, validity, and completeness of the knowledge used for decisions, and dynamically adjust the AI's autonomy according to its current state. As knowledge becomes outdated, autonomy should be reduced, and this adjustment must not rely solely on a predefined checklist. It must take place at the exact moment the AI makes a decision, in other words, at runtime. To operate AI safely, it is not enough to review rules only during design or deployment. The purpose, circumstances, available knowledge, and its level of trust can change with every execution. Runtime governance therefore begins by confirming the purpose, what the AI is trying to accomplish. Next, it identifies the current context, including the business operation, user, target, and associated risks. It then verifies whether the required knowledge is available, valid, and up to date, and evaluates its knowledge trust. The applicable policy and execution authority are also checked to determine decision readiness, whether the AI is ready to execute the decision. If all conditions are satisfied, the action is executed within the authorized scope. If necessary conditions are missing or the risk is too high, autonomous execution is suspended and the decision is escalated to a human gate. The knowledge used, the policy applied, the reasoning behind the decision, any approvals, and the outcome of the action are then recorded as a decision trace. In other words, AI governance is not a fixed checklist. It is a continuous form of runtime control that evaluates conditions and adjusts permitted actions with every execution. Runtime governance also does more than control execution. It preserves why the AI made each decision and uses the outcome to improve future decisions. To continuously improve AI decision-making, we need to record not only the final outcome, but also the process that led to the decision. This mechanism is called a decision trace. For example, when evaluating contract risk, we first record the purpose, contract risk assessment. Next, we capture the context in which the decision was made, including the contract value, the customer involved, and the responsible department. Under knowledge, we record the standard terms, exception rules, and existing agreements that were referenced. Under applied policy, we record the rule actually used, such as, high-risk cases require legal approval. Based on these factors, the AI chooses not to process the case automatically and instead makes the decision to escalate it to a human gate. As the outcome, we record that the legal team reviewed the terms and made the necessary revisions. By preserving purpose, context, knowledge, applied policy, decision, and outcome as one continuous flow, we can later explain and verify why the AI made that decision. But a decision trace is more than a record. Through human review, it helps identify missing knowledge and policies that need improvement. The knowledge is then updated and applied to future AI decisions, leading to more appropriate outcomes. In other words, every decision becomes feedback for improving organizational knowledge. So, how does this kind of knowledge flow work in actual business operations? Let us look at how knowledge flow works in two business areas, manufacturing and contract review. First, consider AI in manufacturing. Sensor data alone may not be enough to correctly interpret an equipment anomaly or determine the appropriate response. The AI must therefore combine equipment design information, past maintenance history, and the applicable safety policy. For example, even when the same temperature increase occurs, the required response may vary depending on the equipment's design limits, its recent repair history, and the surrounding working conditions. The AI evaluates this knowledge and context to determine whether to stop the equipment, issue a warning, or escalate the decision to a human gate. Next, consider a contract review AI. It examines not only the language of the contract, but also the relevant legal policy, existing contracts and individual agreements, and the applicable approval authority. It then determines whether the contract can be approved, whether its terms need to be revised, or whether it should be escalated for legal review. In this way, even when the same AI model is used, the appropriate action depends on the knowledge delivered, the current context, and the policy being applied. Knowledge flow is not a mechanism for teaching AI a single correct answer. It is the foundation for generating decisions that are appropriate for the organization within a specific situation. And the degree of decision-making and action that can be entrusted to AI is determined by the trust created through that knowledge flow. Knowledge flow does more than deliver the knowledge an AI needs. It connects that knowledge with the current context and reveals how accurately the AI understands the situation. Based on this understanding, the trust engine evaluates factors such as the reliability of the knowledge, the AI's capabilities, the applicable policy, and the expected impact. Here, trust is not a fixed score based only on past performance. It represents an expectation about the future, whether this AI can produce a desirable outcome in the current situation. When trust is sufficiently high, the AI may be permitted to make autonomous decisions and take actions within an authorized scope. When trust is low or uncertainty is high, its autonomy is restricted and the decision is escalated to a human gate. After execution, the decision, the action, and their supporting evidence are recorded as a decision trace. The outcome is then reviewed, and the knowledge and policies are updated to improve the knowledge flow itself. This improved knowledge flow enables more accurate context understanding and trust evaluation in future decisions. In other words, knowledge flow supports trust, and trust determines the scope of autonomy granted to AI. Through this continuous cycle, AI governance evolves from managing individual models in isolation into an integrated system that governs data, knowledge, decisions, and actions together. The future of AI governance will not be a single management domain. It will be a system in which multiple forms of governance work together. First, there is model governance. This manages AI model performance, safety, bias, explainability, and versioning. Next is data governance. This manages data quality, ownership, access permissions, confidentiality, retention, and deletion. Then comes knowledge governance. This manages the meaning, relationships, evidence, validity, and trust level of information, transforming it into knowledge that AI can use for decision-making. Decision governance determines which knowledge and policies should be applied, what kinds of decisions may be authorized, and who is responsible for approval and accountability. Runtime governance then evaluates purpose, context, knowledge, trust, policy, and risk at the moment of execution, dynamically adjusting the AI's level of autonomy. These are not independent mechanisms. Knowledge flow connects model, data, knowledge, decision, and runtime governance across the organization. Through knowledge flow, the journey from information sources to decisions and actions, and from outcomes back to improvement, becomes one continuous, governed cycle. AI governance is therefore evolving beyond individual rules and checklists into a system that operates continuously across the entire organization, and the core principles of this system can be summarized in 5 key points. Let us summarize what we have discussed in 5 key points. First, knowledge has a source. Every piece of knowledge comes from an information source. The ability to trace who created it, who manages it, and when it was updated is the starting point of trust. Second, knowledge has meaning. For AI to use information correctly, organization-specific terms, concepts, and business meanings must be clearly defined. Third, knowledge has relationships. A single piece of information is not enough to fully understand a business context. By structuring its relationships with other knowledge, AI can understand the background of a decision and the conditions under which the knowledge applies. Fourth, knowledge has trust. Knowledge must be evaluated based on the reliability of its source, its validity, approval status, freshness, and consistency with other information. And fifth, knowledge controls autonomy. When sufficient trustworthy knowledge is available, AI may be granted a defined level of autonomy. However, when the knowledge is outdated, incomplete, or contradictory, the AI's autonomy must be reduced, and the decision escalated for human review or approval through a human gate. In other words, the model is not the only factor that shapes AI decisions. The knowledge flowing into the AI determines the quality of its decisions, and how much action can safely be entrusted to it. Ultimately, a trustworthy knowledge flow is what leads to trustworthy AI. Trusted knowledge creates trusted decisions. Trusted decisions lead to trusted actions. And only through the continuous accumulation of trusted actions can we achieve trusted AI. The essence of AI governance is not to prohibit or stop AI. It is to determine which knowledge should reach the AI, how that knowledge should be evaluated and connected to decisions and actions, and how much autonomy the AI should be granted according to the situation. It is about designing this entire knowledge flow in a trustworthy way. Govern the flow, trust the decision, govern the flow of knowledge and make the decisions it produces worthy of trust. That is the future of AI governance.